Hi there, folks. Today we're looking at point slope form. And so far, in terms of graphing lines, we've used the slope to extend the line, but we've really been using points to graph those lines, all right? And when we're using points to graph the line, we need at least 2 points, right? Once we have 2 points, we can identify the pattern, which we now know is the slope, and then continue that pattern to plot more points, all right? But the idea today is going to be using the slope to graph. And so here's the thing. If we needed 2 points before to find the pattern, to find the slope, well, what if we only had 1 point, but we already know what the pattern is? Can we count to the second point, and then the third point, and then the fourth point? That's what we're going to do today. So when we're plotting using points, we need at least 2 points. But if we already know what the pattern is, we only need 1 point as like kind of a starting spot for our pattern, for our slope, okay? So graphing using slope, we're going to find a point on the line, and then we're going to use the slope to get the next point and the next point and the next point, okay? So really, to graph a line, we need 2 points, but if we already have the slope, if we already have that pattern, we can get the second point by starting at one other point, all right? For example, if I look at something like this guy, so here I have a point given and then a slope. In other words, that's the pattern. Remember, the slope is just describing the pattern, how far up we go and how far over we go. All right. And so we're going to start at the point that's given. We're going to plot the points that's given and then use that slope, use that pattern to get the rest of our points. For example, in this one, I've got the ordered pair 2, 3. So I plot the ordered pair 2, 3 is right here. And now the slope, the pattern is 1 over 2. And remember, the top is describing the up and down, and the bottom is describing the left and right. So this one says up 1 over 2. And then I could do it again, up 1 over 2. And notice, I now have 2 points, and then 3 points, and then 4 points. And I could continue the pattern the other direction. If I was going the other direction, it would be like down 1, back 2. Okay? But I can continue that visual pattern and now draw my line. And notice I only needed 1 point because that's telling me where to start, and then I use the pattern to plot the rest of the points, okay? The next one, same kind of thing, negative 4, 2. So let's see, negative 4, 2 is right here. So that tells me where to start. So I have a starting point, and now I can use that slope. And here's the thing. That pattern just being a negative 3 doesn't look like slope. It doesn't look like the pattern. The pattern is usually 2 numbers. But remember, any number like this, like the number negative 3, I can write that as a fraction by putting it over 1. So anytime we have a whole number or an integer or something like that, we just want to put it over 1, and now I can see it describing the pattern. The pattern is 3 over 1, but it's got that negative sign. Remember, the negative is describing the direction. So it's saying down 3 over 1. So here I go down 3 over 1. Down 3 over 1, down 3 over 1. And again, if I wanted to continue the pattern in the other direction, I would have to go up 3 and back 1, all right, to make that thing line up. So again, it's all about the pattern recognition here. We use the slope as our pattern, and then we start at that point and use the pattern to plot the rest of the points. If I look at this one, it gives me a starting point of negative 1, negative 1. That's right here. So I plot that point. And now the pattern that's being described is 3 over 4. In other words, up 3 units and then over 4 units. It's giving me directions to get to my next point. So I count up 3 and then over 1, 2, 3, 4. And there it is. And I could keep that going. I could go up 3 over 4 again. And if I wanted to go to the other direction to make that pattern match, I'd have to go down 3 and back 4. All right. And again, the idea of going backwards in the pattern is kind of doing the opposite of each of those things. All right. So instead of going up 3 and over 4, I go down 3 and back 4. All right. Because I'm going backwards in the pattern. That's what happens when we go backwards through things. We do the opposite. And we already know that from solving equations and stuff like that. Okay. All these things tie together. If I look at the next thing, it says 4, negative 3. That's my starting point. So 4, negative 3 is right here. And then the pattern's being described. Notice that negative is out front. Well, remember, you could write the fraction this way. You can put the negative with the numerator instead, all right? And that's typically what I'll do is I'll say, all right, instead of thinking about that, I'm just going to put it with the numerator, all right? Out front or with the numerator means the same thing. So if it's saying the pattern is going up and down, up 1 and over 4, but that negative tells us to go down 1 instead. So it's down 1 over 4, and it kind of comes off my graph a little bit. But so think about the pattern reverse. If taking the pattern in that direction is down 1 over 4, going backwards would be the opposite. It would be up 1 and back 4. And I could keep that pattern going, up 1 and back 4, up 1 and back 4. All right? But it's that idea of anytime we're undoing a process, we're doing the thing backwards. All right? So if the pattern is down 1 over 4, going backwards is up 1 back 4. If I look at something like this guy, and you might be familiar with this form of the equation, but let's pretend we're not. Let's pretend we have no idea how equations in this format work. It has a slope of -1/2. So I'm just telling you it's a slope of -1/2. And yeah, you might notice that that's the value right here. And if you're thinking that's not a coincidence, you're right. It's not a coincidence. We'll eventually get to those and recognize different equations that give us the slope. Okay, we'll see one of them shortly. But then from here, if I want a starting point, I just need to do an XY chart. And see, normally we would do an entire XY chart where we'd plug in a bunch of values, right? Well, this time I'm just going to plug in one value. And again, the idea behind an XY chart is you want to plug in an easy value. And so look at what's happening to X. It's times a -1/2 and then minus a 3/2. And so maybe you'd look at that and go, you know what? I'm going to try something like a 2 because times a -1/2, that's like divided by -2. So let's plug it in, ready? 2 divided by -2 is a -1, minus a -3/2. Uh-oh, I might have to take that off to the side. Minus a -3/2. Oh boy, I got to get common denominators and everything. So this is a -3 over 3. Oh, sorry, -2 over 2. What am I doing? I looked at the numerator like a crazy person. And then that's plus a -3/2. So that's a -5 over 2. Or you can think of it as a -2.5. And if you're looking at that going, oh, that was ugly, I didn't like that. As soon as you started to plug that in, as soon as you ran into an issue, maybe reconsider the number you're plugging in. Like that time I plugged in a 2 thinking it would be helpful with the divided by -2, but it wasn't. So maybe I try something else. Maybe I try something like, I don't know, a 1. All right? Instead of trying an even number, let's try an odd number instead. Ready? -1/2 times 1 is a -1/2. And I'm going to write it down. And then minus 3/2. See, what's nice about this one is I already have common denominators. This one's already working out better than the last one. I changed subtraction to adding the opposite. And now -1 plus -3 is a -4. And the denominator stays the same. Remember, that's how we add fractions. So this is a -4 over 2. Well, what is -4 divided by 2? Remember, a fraction bar is a division sign. That's a -2. So that's a nice, neat ordered pair. All right? And yeah, I could have graphed the fractions. That would have been fine. But it's easier to graph a whole number. So let's see, 1, -2. And again, it's okay if you guess wrong the first time in your XY chart. Just keep plugging stuff in. Heck, I could keep plugging stuff into this XY chart, and I could plot all the points that way. I don't need to use the slope. You can always go back to those previous methods. So now I have a point, 1, -2. It says right here that the slope is -1/2. So that's describing the pattern as being down 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2. If I want to do the pattern backwards, it's up 1, back 2, up 1, back 2, up 1, back 2. Okay? And now I graph this thing. Okay? So now we're going to look at equations in point-slope form. Here's what that looks like. Point-slope form is literally a form of an equation that gives you the point, gives you 1 point on the line, and gives you the slope. And that's why it's called point-slope form. It's literally named after the two things that it gives you. All right? So it's in this format, y minus y sub 1 equals m times x minus x sub 1. And here's the thing, when you see a minus sign in a formula, think of it as an opposite sign. Okay, that's what a negative sign is. It's an opposite sign. Like if I were to give you the number 5 and then give you this, it's saying the opposite of 5. It just so happens that the opposite of 5 is a -5, all right? Negatives are really, when we're talking about numbers, when we just see that symbol all by itself, it's more of an opposite symbol than anything. So anytime you see it in the formula, think opposite, all right? And so what this gives me, we can see m right here. Remember, m stands for the slope. But then this guy right here, the minus y sub 1 and the minus x sub 1, that's essentially giving me an ordered pair. So those three things that I've underlined, they'll be replaced with numbers when we actually go to do this thing. And that first number right here, the minus y sub 1, that's saying the opposite of the y value for my point. Over here, this is saying the opposite of the x value for my point. And then the m, the thing in front of the parentheses, that's just our slope. So really, this is just a matter of kind of memorizing this thing, memorizing this format, and then being able to interpret it, okay? The memorization is by far the most difficult part here. The actual execution of doing the math, actually graphing the line, that's the easy part. That's what we've been doing this entire lesson so far, all right? For example, if I look at something like this guy, if I look at this, I want to identify the ordered pair. And one of the easiest ways to remember which one is x and which one is y is look at which number is with the variable x and look at which number is with the variable y. The number that's with x is the x value for my point, and the number that's with y is the y value for my point. So on this one, again, it's the opposite. So here's the opposite of the x value, okay? So instead of a minus 2, my x value for my point is going to be a positive 2, all right? That's what the minus sign means. It means the opposite. All right, so because there was a minus in my formula, over here, think of this as the opposite of the y value. So that I see a minus 1 there, so my y value is actually going to be a positive 1. It's the opposite, okay? And that's because there are minus signs in the formula. When you see a formula, a minus sign means it's going to show you the opposite of that thing. So when I see a minus 1, I actually want a plus 1. When I see a minus 2, I actually want a plus 2. And then the slope is just the number in front of the parentheses. And again, the slope is describing the pattern. Now we're doing exactly what we did on the previous page, all right? And so again, the most difficult part was actually writing down this ordered pair and writing down the slope. It was interpreting that equation. It was recognizing the format, all right? Once you can do that, once you get past that memorization piece, this part's the easy part. And this is the actual math part. Ready? The point is 2, 1, and then the pattern is up 2 over 3, up 2 over 3. Up 2 over 3. And if I want to do that pattern backwards, it's the opposite. Down 2, back 3. Down 2, back 3. Down 2, back 3. And now I can draw my line. And you don't need to plot all of those points. I'm plotting a lot of points. That's because I'm drawing this thing freehand. If I was using a ruler, yeah, I only need 2 points. All right? But if I'm drawing it freehand, I don't feel like getting my ruler out, I'm just going to continue that pattern a little bit to plot some more points. There's nothing wrong with plotting extra points. It'll just make your graph more accurate, okay? If I look at the next one, all right, here's the x value. I see a negative 3 there, but I want the opposite of that, right? So my point is going to have a positive 3. That is a terrible parenthesis. I can't live with it. I'm ashamed of myself. Let me try again. Oh, so much better. And then over here, this is the y value, but it's the opposite of the y value. So if I see a plus 2, my actual y value is a minus 2. And if you're unsure of why we're doing the opposite, it's literally because that's what the format of the equation said, all right? It's memorization, all right? You know, students never ask their history teacher why was George Washington the first president of the United States? It's not a question of why. It's a question of this is what happened. This is what we know. It's memorization. And it's the same thing here. It just so happens that the format gives you the opposite of that value. So we just have to remember that it's the opposite. Okay. So keep that in mind. There's not a good explanation of why. It just kind of happens that way. All right. And then the slope is right here. It's that value out front that's a negative 2. Again, that doesn't look like slope. Usually it's supposed to be a fraction. But remember, you can always put it over 1. So now I plot the point. 3, negative 2. And then the slope is describing the pattern. It's saying 2 over 1, but it's a negative 2. That's the direction. So it's saying down 2 over 1. So down 2 over 1. Down 2 over 1. If I did the pattern backwards, it would be up 2, back 1. Up 2, back 1, up 2, back 1. Okay? And there it is. All right, if I look at the next one, all right, let's see if we can identify the ordered pair. I see over there with x, I see a +4. So the memorization of the equation tells me that I want to do the opposite of that, so a -4. Over with y, I see a -4, but I know I'm supposed to do the opposite of that, so I do a +4. So that's my ordered pair. The slope is a -1/2. And again, I always write the negative with the numerator, okay? So now I plot the point, -4, 4. And now the pattern being described is down 1/2, down 1/2, down 1/2, down 1/2, down 1/2 all day. I could do it backwards, up 1, back 2 instead. There it is. Too easy. And again, the most difficult part is just writing down the ordered pair, right? Let's check this one out. Over there with the x, I see a -6, but I know I'm supposed to use the opposite, so +6. Over with y, I see a +1, but I do the opposite, so a -1. And then the slope, once again, this time is a -1/2. I put the negative with the numerator. So let's see, 6, -1, whoops, dragged my pen a little bit. 6, -1 is right here. And now the pattern is down 1/2. And I kind of ran out of space. Let's do the pattern backwards. Let's go the other way. To do it backward, instead of down 1/2, I go up 1, back 2. And I could keep that going. Up 1, back 2, up 1, back 2, up 1, back 2. And then if I look at this one, this does not look like point slope form. It looks like something is missing, right? Aren't I supposed to have something right here that shows me what x is? But I don't see anything there. There's literally nothing there. So what number is it? What number represents nothing? When I see nothing, what number is it? 0, all right? And so really this would be the same thing if I slapped a parenthesis here and put a -0, okay? It's no different. All right. When we see nothing, it means the value is 0. So keep that in mind. That's one of those things that students get really tripped up on. But when you think about it that way, really should make sense. If there's nothing there, there's 0 there. There's 0 things there. There's nothing. 0 is when there's nothing there. Okay. So the x value I see is 0. The y value, I see a -2 there, but I know I'm supposed to use the opposite. And then the slope is a -1/2. Again, I put the negative with the numerator. Here we go, one more time, 0, 2. And then the pattern is down 1/2, down 1/2, down 1/2. Or I could go up 1, back 2 if I did the pattern backwards. And I draw my line. Ooh, that was my least pretty line out of all of them. But now here's the thing. When you look at each of these, do you notice anything? All right, what do we notice about the 3 graphs above? Look at each line. It's the same line. I graphed the same line 3 times. It's crazy, right? It's the same line 3 times, all right? So they're all the same. And the point, pun intended, that I'm trying to make there is that you could start with any point on the line and use the slope, and you'll still get the graph of that line. The other thing that's interesting is in point slope form, there are millions and millions of ways to describe each of these lines because it could be any point on the line with the pattern, okay? So keep that in mind. So they're all the same. The reason we don't use point slope all the time is also because of that, all right? Because when we think about making things consistent, it's hard to do that if there's a million ways I can write something, all right? Which is why we're going to have one other version of this thing coming up, all right? But let's write one other equation in point slope form that represents these graphs, and there's a lot of answers here. The point is, you could use any point. So let's pick a point that we haven't used yet. How about this one right here? How about maybe not the x-intercept. Maybe that's a poor choice because that one messes with our brains. How about something like this guy right here? How about this point? The ordered pair 2, 1. Okay, so I could use the ordered pair 2, 1. Let me write that down here. That's a point that's on the line. So now let's think about it. If I wrote the equation, I would put the slope in here, still a -1/2. And now I write the opposite of each of those down. So I put x over here with x, but instead of a +2, I'm going to write -2. I put the y over here with y. Instead of a +1, I'm going to write a -1. There's another equation of the same line, and it's one that I haven't gotten yet, okay? And so keep that in mind. Any point on the line will work. I can start with any point and use the slope from there. Okay?